Okay, here we go again. We are in a new unit. We are looking at squares, square roots, and Pythagorean theorem. So let's get excited about this. So what we're going to do here today, we're looking at relating the area of a square and a square number. So we are, just a real quick, a square is a quadrilateral with 4 equal sides and 4 right angles, right? We have 1, 2, 3, 4. All the sides are the same, and the angles are all 90 degrees. So as we're getting rolling with this, for the start of this, it would be, I would challenge you to do this, not use calculators as we get rolling. Because it'll kind of help in the long run. But if that's what you got to do, that's what you got to do. But I throw that challenge out to you to go calculator free off the hop. So we're going to do a little coloring to start off the day. So let's take a look. We are coloring the shade the following number of squares to see if you can make a larger square. So if we've got 4 squares, so I've got 1, 2, 3, 4. Does this make a square? We've got 2 and 2. Both sides are the same. Yes, it does. It works. Okay. So let's try this again here. Okay, try it with 6. So I'm going to draw 1, 2, 3, 4, maybe 5, 6. Is that a square? No, it's a rectangle. I could maybe go 1, 2, 3, 4, 5, 6. Is that a square? No. Now, okay. So pause me right now and take a look and try out doing 8, 9, 12, 16, 20. If you can't print this, you could do it on just graph paper. You could do that as well, or you could just draw some lines across your loose leaf. Give her a shot. Pause me and come back. All right, we're back. Thank you for pausing and trying. What did you find? Let's see. If you didn't pause, do it now. Okay, good. Now we're back. So we did 8. We found that 8 was a no. Oh, sorry. We found 6 was a no. We don't know what 8 is yet. Let's take a look at letter number 8. If we go 1, 2, 3, 4, 5, 6, 7, 8. If we go long ways, that doesn't really work. What if we go 1, 2, 3, 4, and then we kind of just go around the circle? 5, 6, 7, 8. That does not end up in a square. Almost, but not quite. Okay, so 8 is a no. And what about 9? We have a little hinter here that might work. Let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can make 9 into a square. That works. Okay, cool. So 9 can become a square and 4 can become a square. Okay, cool. Let's take a look at number 12. Let's look at 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. We start with the 9. 10, 11, 12. No, that is going to become a rectangle. Okay. So 12 is a no. What about 16? Let's try 16. Where can we go? Let's go down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we have 16, we can see we've got 4 on the bottom and 4 on the side, and 16 does make a perfect, does make a larger square. Okay, and what about 20? Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And let's just go up here, 17, 18, 19, 20. Is that a square? No, it is a rectangle. We have 4 on the top and 5 on the side. So 20 does not work. Okay, so we've got 4 and we've got 9 and we've got 16. What do those have in common? Right, we have 4 is 2 on one side by 2 on the other side. 9 is 3 on one side and 3 on the other side. 16 is 4 on one side and 4 on the other side. So pause for a moment and ponder this. What if we had 5 on one side and 5 on the other side? Would that be a perfect square? And what would be in the middle? Unpause when you're done pondering. Let's take a look. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It becomes a perfect, a nice little square. And we have 25. We got 5 on one side, 5 on the other side. Okay. So anytime we have that, we can say that we are making perfect squares. So if you can draw a square and it's got the same on one side and the same on the other side, whatever this number is called a perfect square. So if you can take a number and multiply it by itself, it becomes a perfect square. So take a look in here. We've got 1 times 1 is 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. That's what we did. So these numbers here are a, oops, let's not draw over top of everything. These numbers here are a product of this one number being multiplied by itself. 5 times 5 equals 25. 10 times 10 equals 100. 6 times 6 equals 36. 12 times 12 equals 144. If you take a look at these, all of these numbers in bold, these are called perfect squares. So when we've got these numbers there in bold, these are the perfect squares. It would be beneficial for you to memorize these perfect squares. Take a look back to your times tables. Memorize those perfect squares. They will be useful for you as you go through this unit. Okay, let's take a peek over here. So relating to the perfect squares and area. If all the sides of this square have a length of 7, what is the area? So we know it's 7 and 7. Oops, that's kind of a little messy 7. I'll just make them fancy here. Okay, 7 times 7. We know area is length times width. And so we can say 49. Now we know also that this is a square. Both sides are the same. And so this is going to be actually a perfect square. We know that. A square has an area of 144 centimeters squared. What would the side length be? We know that one number times the same number is going to equal 144. This is when I said, it would be useful to have memorized those perfect squares. We know that 12 times 12, if we glance back in here to our list, is 144. So we can look at that and say, okay, we know there's a number that makes 144. 12 times 12 makes that. So we know that this is going to be the same on the other side. Okay, let's take a look here. Oh, a challenge question. I am a square number. Remembering, square numbers, perfect square numbers. Okay, so whatever this number is, it is made by one number. I'm just going to call it n times n. It's the same number. Okay, the sum of my digits is 9. So whatever it equals, if you add them together, blank, 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 is 9. Okay. What square number might I be? So obviously 9 would work, right? You have 3 times 3, and it equals 9. The sum of my digits is 9. There's only one number. It's 9. So it would work. 0 plus 9 is 9. But what other numbers, what other squares could work? What other perfect squares could work if you multiply them together and then looked at the sum of the digits? So example, the sum of 18, 1 plus 8 equals, if I take these two digits, 1 plus 8, I can put them together. That's going to equal 9. Is 18 a square number? No, it doesn't. So you can't use 18. So take a look and see. That is a challenge question for you. Throw it into, I'll post this challenge question into Classroom, or you can send me a message or put it in the comments. What do you got? What is a perfect square? What could the answer to this challenge question be? Okay, awesome. So we'll take a look at that. That's it for our coloring today. You can take a look through the challenge, through some of the questions, see what they look like. If you have any questions, as always, send me an email. We'll hook up with a Google Meet and we'll look at it together. And as always, we miss you. Take care of yourselves, and we'll see you soon.